I am Flash Isaac, and you are welcome to my mathematics class. Today, I shall be taking you through probability. Now, if I say, would you come to my house tomorrow? And you reply, possibly, probably, I would likely come around. Likely. All these refer to probability, which means you are used to probability because probability refers to uncertainty. It refers to possibility. It refers to things likely to occur. It refers to likelihood of events. That is the focus of probability. Probability is a branch of mathematics that is concerned with drawing conclusion from occurrences or experiments involving uncertainties. Now, this class will follow the pattern. 1. The meaning of probability. Terms used in probability. Then, general formula in probability. We shall also look at theoretical and experimental probability. Then, the laws of probability. Addition, multiplication laws. Then we shall look at certain types of events, mutually exclusive events, and blah blah blah. Then we shall look at general questions as well as some things not listed here. At the end of this class, you are sure going to understand everything when it comes to probability, and you'll be able to answer as many questions as possible. Now, let us begin. Probability terms. Now, the first one is sample space, usually denoted by S. Sample space refers to all the possible results in an experiment or in probability. If I throw a die once, the sample space are 1, 2, 3, 4, 5, 6. Because these are the 6 sides. These are all the possible results. Either you see a 1 or the number 2 or the number 3 or 4 or 5 or 6. If I throw 2 dice, the result will be 1 and 1 or 1 and 3 or 4 and 2 or 6 6 or 6 5 or 6 1, which is combination of 2 different throws. Sample space refers to all the possible results. If I throw a coin has 2 sides, the head and tail. Head and tail. Meaning, for a single throw, you have either head or tail. This is the sample space, the maximum number of results or the possible result. Now, if I throw this coin twice, then the chances will increase. For the 2 throw, either head and head appear together, or there is head and tail, or there is tail and tail, or one has tail, then the other one has the head of it. This will be the sample space. Now, in a class of 20 students, what is the probability that a student pick at random is a lady or is a girl? Since we have 20 students in that class, the sample space is 20 because that is the total number of results that is possible. Everything we'll be doing will be within that maximum number of possible results. Outcome in probability refer to possible different or unique results or distinct results of trials. Look at this. If I throw a die once, the outcome will simply be 6. That is the possible result of trial. If I throw a coin 1, I told you the probability are head or tail because we have 2 sides of a coin. So the outcome will be 2. If I throw two coins, the result can either be head head, head tail, tail head, tail tail, which means the outcome has now increased to 4. So 4 is the outcome. Looking at this, outcome is somehow looking like sample space, but it is not sample space. For sample space, when you throw a die once, you are getting 1, 2, 3, 4, 5, 6. Outcome gives you all the values like 1, 1. For example, for a coin, the the sample space is head or tail, which means we are bringing out the sample space. But for outcome, you count each, how many sample space do we have? That is what outcome is concerned about. For here we have 6 sample space, so the outcome is 6. For here, just 2, so the outcome is 2. When you throw coin twice, or 2 coins rather, or coins twice, the chance or the sample space become head head, tail head, head tail, or tail tail. So that outcome is now 4 in total. So take note of sample space and take note of outcome. So experiment simply refer to trial. It is the process of getting outcome in probability. If I don't throw 2 coins, I won't get the outcome. If I don't throw a dice, I won't know the side facing up. I won't even know every other thing to solve. If I don't go to a class to count the number of boys or the number of girls, I won't even know the outcome or what to expect. So I need to carry out experiments to know the outcome. So experiment is the process of getting outcome, or is the process of carrying out trials to get results. After experiment, you get an outcome. You can look for, okay, since these are my outcome, what is the chance of this particular one happen? Now in life, let's say it's either you succeed or you fail. In that case, there are 2 outcomes. So the chance of one happening is 1 out of 2. How about a situation where there are so many possibilities, so many outcomes? You have 20 friends and one is to visit you in a day, or at least 1. So the outcome becomes many because any of them can come. When you hear at most, it means a particular number or below. If you say John should be given at most $100, it means you can give John $100. You can give him $50. You can give him $1. You can give him $5. But don't give him more than 100. At most mean the number that is mentioned, or the value that is mentioned, or the outcome that is mentioned should be the maximum. It can go below, but it should not go above. Then at least, if I say Juliet should be given at least $100, $100 USD, it means if you give Juliet $100, it is acceptable. If you give her $200, it is acceptable. 500 is acceptable, but don't give her below $100. In summary, at most mean, if I say at most something, it means that particular thing or that particular value or less. If I say at least something, or at least a value, or at least a number, it means that number I mentioned or more than the number. Don't give below. Ladies and gentlemen, let's see the general formula for probability. Now we've looked at the meaning of probability, the terms used in probability. Now let's see the general formula for probability. The general formula is simple. Probability is equals number of favorable results over total number of possible results. Number of favorable results over total number of possible results. You can interpret this general formula to your favor, or the way you will understand. This is the meaning. The probability of something happening is the number of what you want to happen or what you want to happen over the total number of what can happen. If throwing a dice will give you 1, 2, 3, 4, 5, 6. If you throw a die, if you've played Ludo before, all those small seeds, that die, once you drop only one, bah! The outcome or the sample space are 1, 2, 3, 4, 5, 6. And for one throw, 1 can only appear once, 2 can only appear once, 3 can only appear once, 4 can only appear once, 5 can only appear once, and 6 can only appear once. So, if I say a die was thrown once, what is the probability of getting a 3? Which means, what is the probability that 3 will show up like this for you to say, I got 3? It is simply the number of favorable results. Favorable result refers to the result you are expecting or the result that you want, and that is 3. So the number of favorable results is only 3. So which is 3 or just 1 out of the total result over the total number of possible results is 6. So 1 over 6. This is your answer. Because the probability of 3 facing up is just 1 out of the total of 6 possible results. If I say in a class there are 5 boys and 15 girls, what is the probability that a student picked at random is a boy? You go back to the general formula. Probability is number of favorable results over total number of possible results. Now, if we have 5 boys and 15 girls, the total number of possible results is equals 5 plus 15. That is 20. True or true? True. Now, since we have 5 boys and 15 girls, if a student is picked at random, the chance that this student is a boy is 5 out of 20. 5 number of students, 20 total number of students. So this is 5 over 20. And that is, when you break it down, you should get 1 over 4. If 20 over 5 is 4. Now, a student sits for an exam. What is the probability that the student is going to pass? Now, for an exam, you have just 2 outcomes: pass or fail. Since you have 2 outcomes, the probability of passing is 1 out of the 2 total outcomes. Simple and straightforward. While solving a probability question, the range of answers is between 0 and 1. You should not get 2 as an answer in probability. You should not get 5 or 10. And you should not get a negative number, -7, -6, -4. The range is 0 to 1, which means you can get 0, 0.5 up to 1. And it is usually in fraction, 1 over something. That is when it is not 0 or when it is not 1. If you are so sure that an event is not going to happen, if there is no possibility of an event happening, or the possibility of an event not happening at all, that you are so sure that this event is not going to happen, then the probability is 0. For sure events, the probability is 1. The probability that there will be 6 a.m. tomorrow is 1, because it is sure that this is going to happen. It is constant, right? So the probability of impossible events is 0. Probability of sure event is 1. Then for event that is not impossible or that is not sure, probability is 1 over something, 1 over something, 1 over something, which is from 0 point something to lesser than 1. That is the range of values for probability or for possibility. Now, theoretical probability is probability calculated without experiment being performed. You don't really carry out experiment. It is theoretical. When you hear of something like this, you are able to respond. Now look at this. If I say a coin was tossed, we toss a coin, you don't need to carry out experiment because we already know what to expect. You can start solving without carrying out experiment. For example, the chance that at least a head will show when two fair coins are tossed is simply, if you have two coins, these are the sample space or the outcome. Either you see a head and a head, because when you throw one, either head face up or the tail. These are the two chances. But throwing two together, one can show head and the other one will show head. Like for Ludo, if you throw two Ludo, you can get 6-6. So that is same thing here. Then there is chance that when you throw the coin again, you get tail in one of them, head in the other one. When you throw again, they can get head in the one that is tail here and tail in the one that is head here, to have head and tail. When you throw again, you can get both of them, tail appears. So tail and tail. Now the question says, what is the chance that at least a head will show when two fair coins are tossed? At least a head will show. Now here we have head and head. Head is showing, at least a head, not two heads. Here and here, you see one head here. Here and here, there is head. But here, there is no head here. So the chance that at least a head will show is 3 out of the 4 possible outcomes. That is 3 over 4. This is theoretical probability. Look at something else. 2 numbers chosen at random from 1, 2, and 4. What is the chance that their sum is even? What is the chance that their sum is even? For things like this, you don't need to carry out experiment. It is just for you to start solving. See, draw a table. The numbers are 1, 2, and 3. 2 of the numbers. So 1's here, the other one, 1, 2, 3. If we begin to add them, the sum of this and this is 2. Then 2 plus 1 is 3. 1 plus 3 is 4. Then here, 1 plus 2, this is 3. 2 plus 2, 4. 3 plus 2, 5. 1 plus 3 is 4. Then 2 plus 3 is 5. 3 plus 3 is 6. So anyhow you do it, if you like begin to sum different versions of the 3 numbers, you should arrive at this. These are the sample space, and the outcome is 1, 2, 3, 4, 5, 6, 7, 8, 9. Total outcome is 9. Now our own required outcome or desirable outcome is the sum of the numbers being even. So let's look at the even results. This is even. 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 If our calculation or solving is actually correct, it means we have 1, 2, 3, 4, 5 even numbers. So the probability of having even numbers from when 2 numbers, 1, 2, 4, are chosen at random, the probability that their sum is even is 5 over 9. This is theoretical probability. Now, apart from the fact that probability ranges between 0 and 1, and for sure event it is 1, for impossible event it is 0, and other values, the probability of something not happening is 1 minus the probability that it will happen. If the probability that Luke will pass an exam is 1/2, the probability that Luke will fail that exam is 1 minus 1/2, which is 1 minus the probability that he passed. The probability of something not happening is 1 minus the probability of it happening. So if I say the chance that something happens is 1/4, what is the chance that it did not happen? It is 1 minus that chance that it happened. And experimental probability are probability calculated using the results of an experiment that has been performed. It is also referred to as empirical probability. Now, anytime you see a table in probability, it is basically referring to experimental probability. Now look at this table. They will tell you that this table shows dice being thrown and the various results gotten. So they threw dice so many times, and these are the results. Look at this. These are the faces: 1, 2, 3, 4, 5, 6. Now this is the F frequency. 1 appeared 15 times, 2 appeared 19 times, 3 appeared 24 times, 4 appeared 12 times, 5 appeared 22 times, and 6 appeared 8 times. From this experiment, it is obvious that the die was thrown 15 plus 19 plus 24 plus 12 plus 22 plus 8, that is 100 times. So they threw this die 100 times, and that was the experiment that was performed, and these are the results. You cannot guess all these results. Without experiment, you won't get this. And if someone else decides to throw die 100 times, the result will not be like this. If another person does the same thing, the result will definitely be different. So experimental probability are probability that can have different results. You can get your option based on your own experiment. If I throw dice 100 times, 1 may not appear 15 times, 2 may not appear 19 times. I'll be able to get different results. So anyone I'm able to get, I put it in table and say, okay, this is what I found out. Then you do your own, tell me what you found out. In questions like this, they can say, find the probability of getting a prime number. Prime number are numbers that have 2 factors. They can only be divided by themselves and 1. Examples are 2, 3, and 5. 2 has only 2 factors, 1 and itself. 3 has only 2 factors, 1 and 3. 5 has only 2 factors, 1 and 5. These are prime numbers. So what is the chance of getting 2, 3, and 5, which are prime numbers? 2 appeared 19 times. So chance of getting 2, the frequency is 19. 3 appeared 24 times. So 24. Then 5, 22 times. 22. So the chance of getting a prime number in this experiment is the frequency of prime numbers 19 plus 24 plus 22 divided by the total number of outcome. All the outcome is equals 100 because the die were thrown or is thrown 100 times. Let's add up. 24 plus 22, this is 46, plus 19, 9. So this is 15, 65 if I am correct. So the chance of getting a prime number is 65 over 100. So this is the probability of prime number. Ladies and gentlemen, so that is theoretical probability and experimental probability. Let's look at the laws of probability. We are not looking at the laws of probability. Laws of probability. When it comes to probability, there are two major laws: the addition law or addition rule, and the multiplication law or the multiplication rule. Now, in a probability question, when you see or either, you need to add. That speaks of addition. Or either signals the addition law of probability. Or either shows addition in probability. But a question comes to mind. If I see a question where there is or where there is either, should I just go ahead and add? No. Addition in probability or additional rule comes in two parts. So when it has to do with addition in probability, you have two types of events. You have mutually exclusive events and non-mutually exclusive events. Mutually exclusive events and non-mutually exclusive events. What are mutually exclusive events? Mutually exclusive events are events where the occurrence of one excludes the other. The occurrence of one excludes the other. For example, if a ball is drawn from a box containing 6 red balls, 4 white balls, and 5 blue balls, find the probability that it is red or white. In this set, if it is red, then it excludes white and blue. If it is white, it excludes red and blue. Meaning, once you get one answer or you are focusing on one, the others does not join. There is no intersection. This will make you understand better. Non-exclusive events are events where both of them share something in common. For mutually exclusive events, if you have two events, A intersection B is equal 0 or null set, because they don't have anything in common. For non-mutually exclusive events, A intersection B is not equal 0. There is something in common. If you look at my video on set theory, you understand intersection. If you've not looked at the video, intersection simply means what sets have in common. So, mutually exclusive events, the occurrence of one excludes the other. They are events that do not have something in common. Meanwhile, non-exclusive events, they share something in common. By the time I solve these questions, example of mutually exclusive and example of non-mutually exclusive, you understand perfectly. For mutually exclusive events, probability when there is or is simply the probability of one plus the probability of the other. But for non-mutually exclusive events, it is simply the probability of one plus the probability of the other minus what they have in common. So, if in a probability question you see or you see either, don't just rush and add and say, wow, I've passed. No. Ask yourself, these events, are they mutually exclusive or non-mutually exclusive? Enough of the talk. Let's do something. Here, a ball is thrown from a box containing 6 red, 4 white, 5 blue. Find the probability that it is either red or white. Red or white means probability of red plus probability of white. How many balls do we have in the basket or in the box? It is 6 plus 4, that is 10, plus 5, 15. So total is equals 15. If total is 15, the probability of red is the number of red divided by the total number. Remember the general formula. The desirable outcome over the total possible outcome. So for red, probability is 6 over 15. Or white plus. For white, probability of white is the number of white balls, 4, over the total number of balls, 15. That is 4 over 15. And this is equals 10 over 15. And this is equals 2 over 3, if I am correct. Now, they do not have anything in common. There are 12 cards numbered 1 to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A card is selected at random, meaning we just pick any card at random without planning or without staging it. What is the probability that it is either even or a perfect square? It is either even or a perfect square. Now let's see the sample space of the outcomes. You say PR, which means probability of even. Let's call it even. That will be 2, 4, 6, 8, 10, and 12. So the sample space is 2, 4, 6, 8, 10, and 12 for even. And the outcome is how many? 1, 2, 3, 4, 5, 6. So outcome is equal 6 for the even numbers. How about perfect square? Let's say probability. Let's call perfect square P. Perfect square is a number that when you look for the square root, you are going to get a whole number. Or here, the perfect square will be, or squares will be 4 and 9. The square root of 4 is 2. The square root of 9 is 3. Any other thing you find square root there, you are not going to get a whole number. After getting your sample space, you ask yourself, do we have anything in common? For even, we have 4 appeared. For perfect square, there is 4. So they have one thing in common or one number in common. So this is intersection. E intersection P is equals 4. That is just one number. Is 1. This is no mutually exclusive event. Now, if it were mutually exclusive, the probability of either even or a perfect square will be even with 6. Total number is 12. So 6 over 12 plus perfect square is, we have two numbers that are perfect square. That is 2 out of 12 total numbers. 2 over 12. But since it is not mutually exclusive, or they have something in common, which is 4, you subtract the probability of getting 4 or of what they have in common. So the probability or even intersection perfect square is 1. They have one thing in common out of the total 12 numbers. Out of 12, they have one in common. So that is 1 over 12. So this is it for non-mutually exclusive event. You subtract how many they have in common over the total. So 6 over 12 is probability of even. 2, we have two numbers that are perfect square out of the 12 plus 2 over 12. Then you subtract one number that they have in common, 1 over 12. I hope this makes sense to you. The multiplication law of probability. We've already looked at the addition law. If In a probability question, you see probability of this and that, or the probability of both this or both and in a probability question, it is a signal that you are dealing with a multiplication question. Now, for multiplication law or multiplication rule of probability, events can be independent or dependent. Under multiplication in probability, you will come across an instance where the event is independent or an instance where the event is dependent. What is a dependent event and what is an independent event? Look at this. If the occurrence or non-occurrence of A does not affect the probability of B, then that is independent event. If you have two events, if the occurrence, the fact that one happens, does not even affect the fact that the other will happen or not, then the events are independent. If the occurrence of A affects the occurrence of B, they are dependent events. Now, for independent events, the probability of A intersection B, or the probability of A and B, or the probability of both A and B is the probability of A times the probability of B. Just the way we did in addition. If it were and instead of or, just multiply. For dependent events, the probability of A and B or A intersection B is probability of A times probability of B, knowing that A has already occurred. Now, if in probability question you hear or you see replaced, that shows independent. If you see without replacement or not replaced, it shows that the event is a dependent event. Now, this question will do justice to both independent events and dependent events. 3 balls are drawn successively from a box containing 8 red balls, 6 white balls, 4 black balls. Find the probability that they are drawn in order red, white, and black if each ball is 1 replaced, 2 not replaced. We are given 3 balls, red, white, and black, and these balls are drawn successfully. We are taking the ball successively. Now, it says that 8, 6, and 4 balls. Find the probability that they are drawn in order red, white, and black if each ball is 1 replaced and 2 not replaced. If the balls are replaced, then it is an independent event because the probability of getting, okay, let's see the number of balls. We have 8 plus 6 plus 4, and that is 18 outcome. The total outcome is 18. Out of this 18, the chance of picking a red ball is 8/18. After picking the ball, a red ball, and you replace it, right? Find the probability that they are drawn in order red, white, and black if each ball is replaced. So, if you take a red ball out of the balls, the chance that the ball you are taking, or you take a particular ball out of the balls, the chance that it is red is number of red over total number of balls. That is 8/18. Now, taking a ball out of 18 balls, you are left with 17. They say, okay, it is replaced. You now put the ball back. Taking it back, total number of balls goes back to 18. Then you pick white. We have 6 white balls. So the chance of picking the white still remains 6 over 18. Because you picking the red ball does not affect the chance of picking the 6. You replaced the one that you took. And we have 4 black balls. The chance of picking a black ball is still 4 over 18. At every point in time, the total number of balls remain the same. This is an independent event. And since we are dealing with multiplication, the chance of picking red, white, and black ball in order is 8 over 18 times 6 over 18 times 4 over 18. That is it with replacement or for independent events. How about for dependent events? This is what happens for dependent events. For dependent events, there is no replacement. It is not being replaced. So, what would happen? Total balls 8 plus 6 plus 4. This is equals 18. Total remains the same. We are picking red, white, and black in order, and we are not replacing them. Now, since we are starting from red first, if I'm taking red out of 18 balls, the chance of the ball being red is 8 over 18. Now, I did not put back the red ball I took. I took one, I did not take it back, which means the numbers remaining will be 17. That is probability of B, knowing that A after A has occurred. If I now go again to take a white ball, probability of picking a white ball becomes the number of white balls, 6, over total number of balls. It is now 17 instead of 18. Then I also did not replace the second ball I took, meaning I've taken 2 balls out of the box or wherever. I go again to pick black. There are 4 black balls. The chance of picking this black is now 4 over 16, because as you take and you are not replacing, the total begin to go down and go down and go down. So this is red 8 over 18 times white 6 over 17 times black 4 over 16. This is the probability of picking without replacement. Once you don't replace, the total balls begin to drop. And if you are told the probability of picking just red and white and black is not included, it will be 8 over 18 times 6 over 17. So that is basically it. Multiplication laws of probability. In a group of 200 students, 117 enrolled for mathematics, 133 for statistics, and 95 for both. This is a question involving 2 sets, which is something like this. Something like this. The universal set is equals 200. Now let this place be for mathematics and let here be for statistics. Let here be for both. Now, out of the 200 students, 95 enrolled for both mathematics and statistics. And they said that 117 enrolled for mathematics. They did not say 117 enrolled for mathematics only. They said for mathematics, which means out of those who enrolled for both mathematics and statistics, some of them, out of those who enrolled for mathematics, some of them also enrolled for statistics. And they said that 133 for statistics. They did not say 133 enrolled for statistics only, which also implied that out of the 95 enrolling for both, or out of the 133 that enrolled for statistics, some of them also enrolled for both. Now here, we are looking for those who enrolled mathematics only. Here, we are looking for those who enrolled statistics only. For only mathematics, it will be 117 minus 95. That is 117 minus those who enrolled for both. For those who enrolled statistics only, it will be 133 minus 95. 133 minus those who enrolled for both. Now let's look at this. 117 minus 95 is 2. So this is equals 22. 22 enrolled for only mathematics. 133 minus 95. 133 95. 13 minus 5 is 8. 9, 10, 11, 12, 38. So this is equals 38. 38 people enrolled for only statistics. Now let's add them. The number of those who enrolled for mathematics, both mathematics and statistics, and only statistics, is equals 22 plus 95 plus 38. This should be 155 if I am correct. So 155 candidates registered for at least one of the two subjects. Look at something. We have 200 students in total. Now, out of the 200 students, only 155 registered maths, statistics, or both of them. This implies that 45 students did not register any of them. So, what have we gotten so far? Total number of students, those who registered only maths, those who registered both, those who registered only statistics, and those who did not enroll for any of the subjects. A bag contains 36 balls. Total is equals 36. Now, out of these 36 balls, some are white, some are yellow, and some are blue. Meaning we have white, yellow, and blue balls. Blue balls. If a ball is chosen at random, the probability of getting a white ball is 1/18. Now, they gave us probability of white ball. So the probability of white is 1/18. And that of getting a yellow is 1/3. So probability of yellow is 1/3. Take note, these values are not the number of white balls or the number of yellow balls. They are probability, the chance, the possibility of getting these ones. But the question is saying, how many blue balls are in the balls? They did not say we should find the probability of blue balls. They said how many blue balls. If they had said probability of blue balls, it would be easy for us because the total probability is 1. Probability cannot exceed 1. That would have been probability of white 1/18 plus probability of yellow 1/3 plus probability of blue. Everything here is equals 1. So if you make blue or B subject formula, any answer you will get is going to be probability of blue ball. You can actually solve the question that way. Yes, let's do it that way. LCM here is 18 and this is 1 plus 6 plus B is equals 1. 1 plus 6 is 7. So 7/18 plus B is equals 1. And B is therefore 1 minus 7/18. And cross multiplying, this will give you 18 minus 7 over 18, and this is 11 over 18. So the probability of getting a blue ball is 11 over 18. But the question says, how many blue balls do we have? Remember, from the general formula, probability is obtainable over total. The number you can arrive at over total is equals probability. Now we have probability, and that is 11 over 18. We have the total number, that is 36. So over 36. Up here will simply be the number of blue balls. Cross multiplying blue balls is equals 36 times 11 over 18. 36 times 11 over 18, this is equals 22. So the number of blue balls is 22. So this was not the formula I planned to use before, but it works perfectly. Since total probability is 1, so probability of white given plus that of yellow plus that of blue, everything will give us 1. So making blue subject formula, probability of blue is 11 over 18. And we know that probability is number of blue balls over the total number of balls. Probability of blue is number of blue over total number. Probability of blue is 11 over 18. This is equals total blue balls over total number of balls, that is 36. And total number of blue balls is 22. So this is more straightforward than the method I wanted to use. And this will go a long way. Ladies and gentlemen, this brings us to the end of probability. And I trust you found this class interesting. If so, let me know how you feel. Subscribe to this channel to get more amazing videos. Check out the various playlists for other subjects. And don't fail to tell people how you feel about this. Thank you. Take care of yourself.